Hello and welcome to the Tau update in June, and you're here with me, Fola. So without further ado, let's get on to your questions from the Q&A. And this first question is from Sam, and they ask, has it been decided what social choice system Tau will start with? Does it compare to any existing system?
So we are still working on the social choice system for Tau. The idea is that the initial system will be something that is very much based on consensus, and then it can be replaced by other systems where majority decisions can be made through some kind of preference voting, for example. This is the important thing is that decisions can also be made within the system about which social choice function will be used. And we will provide a framework in which different social choice functions can be discussed and debated and voted about. And then, well, of course, the first social choice function that we use at the beginning is going to be the one that decides the details of this voting procedure to decide for later social choice functions. Yes.
All right. Thank you, Dr. Kramer. And this next question is from Dan. And they ask, how Tau determines the ordering of issue votes, agenda setting, the rules that manage this process, parliamentary procedure, the types of issues that Tau votes on, policy content, and whether factions organize around dissension on predictable issue dimensions, political parties. I'm interested in these questions of how Tau organizes collective decision-making as distinct from the question of what kind of voting system is adopted, for example, quadratic voting. Although it would also be interesting to think about whether different voting systems are more compatible with certain models of parliamentary procedure. I'm coming from a political science background, so it would also be interesting to talk about whether these analogies make any sense to Tau users.
Yes, so I think your question is actually quite interesting, and you raise some important issues that we will have to deal with when we work out the details of how the social choice decision procedures in Tau are going to work out. We will, however, not very closely follow, let's say, existing systems of parliamentary procedures, because we have a different approach of having a computer system that supports consensus finding by people just saying their opinions at the same time. Basically, in parallel, they can enter their opinions into the system, and then the system computes consensus or majority decisions, things like that, which is a bit different from parliamentary procedures where it's important in which order certain things are decided. We will work on decision methods that are not so dependent on such procedural questions. Yeah, I think this is the main thing I have to say about this question.
Thank you, Dr. Kramer. And this next question is from Lucy, and she asks, what are the main differences and benefits of Tau over Tim Berners-Lee's project, Solid?
Berners-Lee's project on Solids is actually about just data storage with sophisticated user access. Not unlike IPFS, but IPFS doesn't have very good user access control. So as such, I mean, it doesn't overlap too much with Tau, but we could possibly use it for storing some of our data.
All right, thank you very much, Kevin. And the next question is from Gregory, and they ask, what does AHAD make of programming languages like Catala, a programming language for the law, and legalese, a non-Turing complete language? Is Tau's language used for smart contracts as powerful or comparable?
All known formal languages, whether they deal with law or not, are unable to express the law of changing the law, which has to do with asking about statements in the language itself, whether they contradict other statements and so on. And we are the only one who were able to crack this important problem. So I don't expect Catala or legalese to be able to do such a thing. Further, we also adapted to speak about time ordering of statements. So not only whether it's true or not, but the way they appear in time, and this is important for software specification purposes. So I would expect that on this front, the languages are very different. Whether everything expressible in Catalan or Legalese can be expressed in the languages that we work on, I don't know. As long as a language is decidable, and this is a propositionally clause, so you can take the conjunction, disjunction, and negation of any sentence, then we can add our support of language that speak about its own sentences, as well as ordering in time of sentences as a language extension to that language. So our solution is really open-ended that applies to virtually all languages. So in principle, there is no limitation to adapt everything what those two languages can express in our setting.
All right, fantastic. Thank you so much, Ahad. And the next question is from Jamie, and they ask, digital governance systems often require precise specifications due to the nature of software, but a General Motor versus Japanese car makers case study suggests that this is counterproductive. The case study suggests Japanese car makers are more successful as they have more of a back and forth with their manufacturers. Japanese car makers want the parts to fit the car, where Ford wants the parts to fit the blueprint. Is there an approach that embraces the relational contract model when collaboratively writing code? When you are writing code, you have to be precise about how you specify something, and it is hard to create a relationship-focused approach. Does Tau approach digital governance in a way that embraces this relational contract model? As a further example, we design interfaces to be stable. When building an API where people depend on it, you don't want to cause breakages. Is there a way of building flexibility and change into an API whilst maintaining stability and reliability?
Yeah, so for the first part about specification, indeed, specification can be taken in two ways. One way, which is not the way we speak about, you could say that any program is also a specification. After all, it specifies itself. But then it is meaningless to ask where two programs agree on. Another kind of specification, which is what we deal with, is to just say something about program, not necessarily everything, but to say something. And by that, you implicitly intend all possible programs that admit this requirement. For the second part about breaking the API, that's why we need the law of changing the law. So you want to say something of the form, any future update, any future version of the software is rejected if it does not satisfy certain requirements. So that's how we address this front, and we put a lot of effort into precisely this thing.
The next question is from Sir Andrews, and he asks, could we say that homograph Trojan source attack that hides invisible bugs on source code poses a serious threat to current programs that is a major advantage to Tau, since Tau is able to verify codes to meet user specification, but other programs needs humans to do these verifications? And second, he asks, will the dev team do another TML benchmark? To which language to compare it and why? And then he asks also that, could we say that Agoras Live deals with tacit knowledge or implicit knowledge, a kind of knowledge transferred by coaching, training, since it is too complex to code? Teacher gives specific answers to specific problems. Can we say tacit knowledge would be the major difference between other online sources offered, which offers explicit knowledge or codified knowledge? Yes, and also decentralized, so anyone can set their price for their knowledge and no middleman to cut your money. Thank you. That's Sir Andrew's question. I can answer the second question. We certainly develop continuously benchmarks all the time for TML, and probably the closest language that is comparable to TML is, of course, Datalog. It's very close to TML. That's the answer to the second part. And let me also answer the first question. Certainly, the Tau logic engine can detect harmful content in any program specification and detect that, whereas naturally it'll be very logically complex to do so, but to the extent that we have the computing power available, we can do that, yes. And the answer to the third questions.
The answer is yes, of course. Agoras Live initially deals with partly implicit knowledge, meaning that teacher is sharing whatever knowledge he possesses on different topics, and also a little bit later there will be a market of questions which you can answer as a teacher for whatever price you want is set on the market. And also, of course, there is no middleman. You set the price for your knowledge by yourself. But on the other hand, in some more distant future, we can imagine other ways of sharing knowledge. For example, you can code your knowledge in, for example, if you're a lawyer and you know some answers on some questions, you can write logic software that answers automatically on some questions and just provide an access to your coded knowledge for some fee. Why not? But yes, initially you share your knowledge via video conferencing calls, or you answer to people requests for knowledge via video conferencing calls without any middleman in the middle. Yeah, all money goes only to you. That's right.
Thank you, Andre. Thanks for that answer. In my opinion, I think to answer the question succinctly, I think knowledge in Agoras Live is implicit, not explicit, because users have to express their opinions using a controlled natural language or any other knowledge representation language explicitly. They really need to make that explicit. We don't necessarily deal with tacit knowledge for the most part. Would you agree, Ohad?
Well, in some sense, yes, but in some sense, no. In some sense, the whole point in using logic is to mean things that are not explicitly written, but can be inferred.
Okay, that's good. That's good explanation. Thanks, Ohad. Moving on to the next question. Andrew asks, when Agoras Live is ready, 1, should users transfer their Agoras tokens in MetaMask wallet to Agoras Live wallet? Or 2, are users able to open their existing MetaMask wallet and Agoras tokens and use it in Agoras Live platform? I think option 2 is better, as this would avoid friction in using the platform, such as transaction fees. This will also make the platform more open and convenient to use. What do you think, Andre?
So, Andrew, almost from the beginning, Agoras Live is a Web3 application, meaning you connect directly to your wallet. It can be Fortmatic wallet, it can be MetaMask wallet, or currently to any wallet that supports Wallet Connect. There is no extra Agoras Live wallet you need to create and transfer your funds to. So you use directly your cryptocurrency wallet, and that's it. Thank you.
Excellent. Thank you, Andre. And the next question is also from Sir Andrews. He asks why the project needs alpha. Number 2, he asks also, what do participants need to participate in the discussion? Should they pay with Agoras tokens? And what kind of discussions are to be expected in alpha? And who is to choose to pick the subject of discussions? Let me attempt to answer those questions in reverse order. What kind of discussions to be expected on alpha? Any discussions really that the users would like to discuss. We're certainly not going to limit the topics of discussions there. And then what do you need to participate in discussions? Just a web browser to connect to Tau. And would you pay for Agoras tokens for discussions? No, we project that discussions, at least in the most general topics, will be free. You will not be asked to pay in Agoras. The only time you will ask to pay is if there are any specific knowledge that the Agoras users want to get paid for. In that case, you can transact with them directly. There's no payments to us for that. And the first part of the question is, why does the project need alpha?
Well, basically, virtually any software needs alpha for testing purposes, for some starting point, to have some of the features, but not all, the usual considerations.
Great, thank you, Ohad. So the next question is from Brenda, and she asks, in TML state blocks at tml.tau.net, I encounter the runtime error when I run the code. What does it mean? Runtime error saying state blocks require -SB option enabled. That's a question for Tomasz, please.
Yeah, so the state blocks feature is disabled by default at the moment. To use state blocks, TML requires a command line option SB or state blocks to enable it. On tml.tau.net, it is possible to enable it in the settings panel, which is available on the top right, and you can check its checkbox to enable it. It was I usually, when I add a feature, I make it disabled by default, and then if it's fine, then I make it enabled. So it never happened the moment. So maybe we can enable it by default now.
Excellent. Thank you, Tomasz. This next question looks like it's probably for you as well. In char escape in tml.tau.net, why are some character combinations have the same output? What does it mean? What is it a function of or use? Thanks.
Yeah, we support different ways to encode characters. This way, it is possible to encode a character if you don't have the character available on your keyboard or in your font, or if you cannot use an Unicode encoding for the source file. So the \x is for symbols 0 to 256, and \u is for symbols 0 to 65,535. And this \u, it enables to encode any Unicode symbol.
Thank you, Tomasz. Thank you. And the next question is addressed to me. Let me read it out from Red. In the previous update, it was mentioned by Kareem that Tau chain will not offer interoperability towards other blockchains. But then the very same statement says reaching out for partnerships. How does that work? And won't interoperability be highly crucial for the platform growth? I mean, we're certainly open for cooperation with other blockchain projects. I think the question, if I remember correctly, last month was related to a direct transactional connection between blockchains, and I said that currently we don't have any plan for that. But if the need arises, I mean, we're certainly open to it. It's just that currently we don't have any plans. And the next question is from Uza. He asks, what does self-referential mean?
In general, self-reference means a statement that speaks about itself, like the liar paradox. And in the scope of Tau, there is the white paper speaks about certain kind of self-reference in the section about logics for law and the law of changing the law, and languages that support this. But since the white paper, we made huge progress on this front. And now our self-reference is not as strict as mentioned there. It is about a language that can speak about its own sentences, and more direct self-reference, like a constitution that says what happens if a new law contradicts the constitution, that's a direct self-reference, is handled by well, it's a little complex to explain, but the idea is that self-referential statements as for themselves don't make sense. So if it is possible to write it in a way that makes sense, then we write it in a way that makes sense without self-reference. And if not, then the statement is rejected.
Thank you, Ohad. Thanks. Okay, next and last question is from V. He mentions, Ohad has previously pointed out that the complexity of problems expressible in Tau is far greater than those in statistical or machine learning. Could you point out examples of scientific problems that seem major and that Tau technology could help solve?
Yes, more precisely what I said is that logic can do machine learning, but machine learning cannot do logic. And the mathematical proof for that is by using complexity theoretic argument. That machine learning is under a certain complexity class and logic is under a bigger complexity class. And that would be a mathematical proof that indeed logic can do machine learning, but machine learning cannot do logic. For a scientific example, the difference between machine learning and logic is all about how you communicate with the machine, how you communicate with the AI, how do you say what you have to say. In machine learning, your only way is to provide examples. Imagine that the only way you could communicate with others is by giving examples. That's definitely not useful. Sometimes you need to say the thing, not just give examples. And moreover, the receiver, when they see only examples, what are they going to do with an example that they didn't see yet? They can only guess. So you can make educated guess, and that's what machine learning is all about, but you will never be certain. In logic, you can just say the thing, whatever the thing is, and whatever implied from that will be understood with absolute certainty. So let's just take a crazy example to say that nothing moves faster than light. So in machine learning, you will have to give many examples of how fast things move. And then when you ask how fast something moves, it will hopefully tell you not greater than the speed of light. And that's definitely not the way to go. In logic, you can just say speed is always not greater than the speed of light. And that's it.
Excellent. That's a great example, Ohad. And that wraps it for this month Q&A questions. Please keep them coming. We'll answer them next month. Thank you very much.